In this video, we're going to look at topic 77, example 2, understand end behavior of polynomial functions. So this will be another video where there'll be a lot of talking and not too much doing, but we want to go over these polynomial functions and understanding what the end behavior looks like. And this is one of those things that once you understand, it makes a lot of sense and it makes other processes much easier because you know what your functions are supposed to look like based on a couple of key features, we'll say. So in this first upper left box, the odd degree and positive leading coefficient. So we're looking here, odd degree, positive leading coefficient. Remember that the degree is the highest power. So if we look at that first function, f of x equals x, the highest power is 1. G of x would be a degree of 3 because the highest power is the third degree, and h of x would have a degree of 5. So all of those are odd degrees. Now, the positive leading coefficient, we have a 1 here, we have 0.5, and we have 2. So those are all positive. And what we're looking at here is the end behavior. So if we look at, say, the red line, our linear function, going to the left, this is going down, and then on the right here, it is going up. So your end behavior is down, up. All right, and the same thing for g of x. The left side here is going down, and the right side is going up. And our h of x, the left is going down, and the right is going up. So the end behavior is down, up. Now again, that might not seem very significant, but as you go through these, and especially this lesson, you'll start to see that this becomes pretty useful. One of the shortcuts to remembering this is if you can just remember the end behavior is similar to the linear parent function f of x equals x. So if you know that just x is that red line, anything that has similar, or anything set up similar where it's positive to start and an odd degree will always have down, up end behavior. Okay, looking at the second group where we have an even degree and a positive leading coefficient, what happens here is that you'll notice all of our end behavior for the red, the blue, and the green, all of them are going up on the left side and up on the right side. So your end behavior is up, up. And all of these even degrees with positive coefficients are going to be similar to the parent quadratic function of x squared. Again, this will seem insignificant, but as you kind of get the hang of this, it'll seem a little bit more useful. Just moving right along. Odd degree, negative leading coefficient. So all that's happening here is notice that these are the same polynomials as the one right above it, but all we've done is we've changed the degree. Sorry, not the degree, the terms, each term is the opposite sign. So in the original one up here, we had f of x is equal to x, now it's negative x. Here we had a positive 0.5, now it's a negative 0.5, and all the other signs are switched as well. Okay, so just to show some similarity between them. In this case, my end behavior on the left side, it's up, and then it goes down. So up, and then down. Notice how it's the opposite of what we had above. So it's still odd degrees, but by switching the leading coefficient to a negative number, we've changed the end behavior, right? It's a reflection. Instead of down, up, it's now up, down. And finally, our even degrees with a negative leading coefficient. So this is similar to the one above, right? We had even degrees with positive. Now we have even degrees with a negative leading coefficient, which tells us that there's been a reflection. So our end behavior, instead of being up, up, is down, down on all of these. So this would be down, down. Again, not too much significance really right now, but you will get the hang of it. I know I've said that a couple times, but it'll start to make sense. Because of the size of these graphs and how much space they took up, the next chart is just kind of a shortcut that you can use. So here we have a positive leading coefficient with odd degree. That's our first example, positive leading coefficient with odd degree. That has an end behavior of down, up. So you can just use this as a reference chart. Positive leading coefficient with an even degree. That's that top right. That would be up, up. Odd degree, negative leading coefficient would be up, down, and negative leading coefficient with an even degree would be down, down. So this is just a reference kind of chart or a little table that you can use. But it does help if you can start to get familiar with these. And you don't have to obviously memorize every single one of them, but the spots where I've put the little stars, if you can remember the end behavior for those parent functions, everything else kind of falls in line with those. So hopefully that makes sense, that part. If it doesn't, you will get some practice and eventually it'll start to click a little bit. But the nice thing is you can always graph these and you can always look at the end behavior that way. Knowing it ahead of time will save you some time and will definitely make things a bit easier. So go through this, review it, try to make sense of it, and hopefully it clicks after a couple tries.